Well, I said I would get you a video about completing a square and putting a quadratic equation into vertex form. So see if this helps you out and can make sense to you. If not, let me know. So the idea here is we're trying to get to that standard form of what a vertex, or sorry, this is the standard form. What I want to get to is the vertex form, and that looks like this. And there we go. And that makes the vertex at h and k. So minus h plus k. So um, the key part of this is that this is one thing squared. So what I need to do with this is the first idea is separate that constant outside here. Put the constant, just physically kind of create a space. And we're going to fill in something here. I'm looking for the number that will complete the square. Well, the number that does that, you take the b term and you take half of it and square it, and that's what you need to add. So when I add 36 in there, I've completed the square. But because it's an equation, I would also have to add 36 to the other side, but I don't want to mess with this other side. So instead of adding 36 here, I turn right around and subtract 36 from the same side. Seems kind of dumb that you're going to add it and turn around and subtract it. But what it does is creates for you a trinomial that is a perfect square. That trinomial will factor into two identical things. It's going to be minus 6 and minus 6. So instead of writing it as x minus 6 times x minus 6, you write it as x minus 6 squared. Then, of course, the 4 and the 36 come together and get you negative 40. There it is in vertex form, and you can easily read off what the vertex is. Let me go back. Oh, sorry, there it was. You can get the vertex very easily from minus h is 6, plus k. So think of this as plus negative 40. So 6, negative 40 is the vertex. And then because the leading coefficient on this was a 1, that's a 1 back there, that means is you're going to do the normal parabola. From this point, from the vertex, there's the vertex down there, from that point, when you go right 1, go up 1. When you go left 1, go up 1. When you go right 2, you go up 1, 2, 3, 4, because 2 squared is 4. So from that point, you can begin to figure out what the graph looks like. Now there's another point that's kind of nice. That's the y-intercept. And back on the original equation, the y-intercept, the constant term was negative 4. And remember, any point that's on the y-axis that has an x-coordinate of 0. So if you put 0 into that equation, you get negative 4. So I can plot the point negative 4. And then the axis of symmetry goes right through the x-coordinate. So the vertical line, x equals 6. Well, axis of symmetry, the balance here, this is from 6 to 0, so that was 6 units this way. So then 6 units the other way, you'll have another point just like it. So you can kind of begin to figure out what the coordinates are. This is the point 0, negative 4. That would be the point, because I'm 6 units past this, 12, negative 4. Those 3 points are enough for you to figure out what the parabola looks like. That's it. Let's do one that's a little bit different. Oh, by the way, so if you wanted some other points, remember how I said from the vertex over 1, up 1? Well, that's what I did here. From 6, negative 40, if I go over 1, I would be at 7, and then up 1 would take me to negative 39. Or the other direction, left 1, so to 5, and then up 1 would take me to negative 39. All right, a little difference on this one. The difference is that this is not a 1 anymore. So there's a little bit of a trick. In order to do this, the completing the square step, the a has to be a 1. So what I'm going to do first is factor out the negative 2. But notice I didn't take it out of the constant term, because remember how that just gets separated down there? We're not going to worry about it. We're just going to look at the first 2 terms that have the variables. Fortunately, they both could factor out a negative 2. If it couldn't, nothing changes in the logic of the problem. It just becomes a little trickier to deal with fractions. Like if that was a 7x instead, and you tried to factor a 2 out, well, then you'd have a coefficient of 7 halves. And then you'd have to take half of that, and then square that, and then add that, and subtract. It's doable. I just want to make sure we get the basic concept down for now. So Now that I've got this separated, I create this little space down here, and I'm going to look to go figure out what's in there. Half of that term squared. So half of 4, 2, 2 squared, 4. Add 4 there. And then on the outside of the parentheses, you have to subtract. Sort of. Now here's a twist to this. Remember that what I just did by putting a plus 4 here really had the net effect of doing negative 8. So to counteract this negative 8, right? Negative 2 times 4 is negative 8. I have to do a plus 8 on the outside. So putting 4 there is the same as putting negative 8 on this side. To counteract negative 8, positive 8. Now, this will become a perfect square. I can write it as one thing squared. So there's your vertex at positive 2 and 13. So positive 2, 13. Now, one of the key things to this is because of that negative, that means that this is an upside down parabola. So this is going to be a maximum point. Now, here's another change. Because of the 2 out front, remember how it was like over 1, up 1? Well, the negative means that you go from the vertex, you go over 1, down 1. And then the 2 means you go down twice as far. So from the vertex, you're going to go over 1 and down 2. And then over 1 and down 2 to the next point, not just down 1. So look what I've done here. I went from this point, if I go over 1, I'll go down 1 times 2, which would be down 2. But then if I go over 2 spaces, normally you would go over 2 and down 4, but because of the 2, I'm going to go over 2 and down 8. So from 13 down 8 takes me to 5. Now, I could have also seen back in the original equation that 5 was the y-intercept because that's the constant term at the end. Then we just fill in the parabola, and there you go. Hopefully this helps you, make sense to you, helps you understand what's going on with that completing the square. This is a better way of getting to the vertex form because this process of the completing the square comes up a lot in some other areas.